In this lesson, we're going to solve a system of linear equations, and we're going to do this by graphing. And so we're going to review a concept you learned in a previous course. So let's review how to graphing a line. So this is going to be review, graph a line using slope and y-intercept. All right, so when we solve a system by graphing, we're going to use slope and y-intercept. All right, so remember slope-intercept form? So slope-intercept form, remember, is y equals mx plus b. So that's slope-intercept form. So the coefficient of x is your slope. So that m right here, that's your slope. So that's your slope. And then this constant b, that constant is your y-intercept. That's where the graph will cross the y-axis. Okay? And so if I want to graph this line, y equals negative 1/2 x plus 4, if I want to graph this line, then it's already in slope-intercept form. So y is already by itself. So that means that the coefficient of x is your slope. So my slope here is negative 1/2. And my constant b, that's your y-intercept. So that's a positive 4. Okay, if this were negative 4, then b would be a negative 4. Okay, so keep that in mind. You got to keep that sign with it. And so b here is a positive 4. So remember, that's your y-intercept. That's where the graph will cross the y-axis. And remember, to graph a line, you need 2 points to graph a line. And so to graph this line using slope y-intercept, I already know one of the points. So one of my points is this y-intercept. So that's where the graph is going to cross the y-axis. All right, so right away, I can go to my grid, and on the y-axis, I can plot this point right here, and that's where the graph's going to cross the y-axis. Okay. Now the fact that your slope is negative, remember, if the slope is negative, that means that your line is falling. So it's going down like this. All right. If the slope were positive, remember, your line is rising. All right. So the fact that my slope is negative, I know I better get a line that falls. All right. Okay. So remember, to graph a line using slope-intercept, or to graph any line, we need 2 points. I already found one. And to find the other, I'm going to use the slope. And we're going to also use the fact that the slope is rise over run. Rise over run. And so in this case, my rise is negative 1. Okay, so remember, if your rise is positive from that y-intercept, you're going to go up. If your rise is negative, you're going to go down. If your run is positive, you're going to go to the right. If your run is negative, you're going to go to the left. Okay? So rise is up and down. Run is left and right. So if your rise is positive, you go up. Rise is negative, you go down. Run is positive, you go right. Run is negative, you go to the left. Okay? All right. Now, remember, to graph a line, we need 2 points. And so we're going to use this slope here. So slope is negative 1 over 2. So my rise is negative 1. So that means from this point right here, not the origin, that's a common mistake, it's from this point, from the y-intercept. From that point, I'm going to go down 1. So that's where I'm at. And then my run, remember, is 1/2. My run is 2. So that means I'm going to go to the right 2. So 1, 2. And so there's your other point. Okay? And so now all you do is you take a ruler, a straight edge, and you draw your line. Okay, take a straight edge and draw your line. Just like this. Okay? And so this is a line, y equals negative 1/2 x plus 4. All right, so we graph this line using slope and y-intercept. So we use slope-intercept form. Okay, now remember, one more thing I gotta mention to you, I got to remind you about before we solve a system by graphing, is that if you remember, you have an equation here, right? That's an equation. And so the solution to this equation is any point on that line. So any point on that line is a solution to that equation. So if you notice that this equation has an infinite number of solutions. So any point on that line, if you substitute here, will make the left side equal the right side. Will make this equation true. Okay, so for example, see this point right here? 4, 2. Is 4, 2 on that line? Yes, it is. So what does that mean? That means that if I substitute 4 into x and 2 into y, the left side is going to equal the right side. That's what that means. So 4, 2 is a solution. See this part right here? 8, 0? 8, 0 is a solution. Any point on that line is a solution. This point right here, whatever that is, it's not lying on one of those nice little intersections here, so that would be an approximation. But any point on that line is a solution. So how many solutions does this equation have? An infinite number of solutions. Remember when you talked about graphing these lines in a previous course? Is this point right here a solution? No, that's not a solution. The point 6 is not a solution because it doesn't lie on this line. So if I were to substitute 6, 6 in here, negative 1/2 times 6 is 3. 3 plus 4 is 7. 7 doesn't equal 6. Okay, so 6, 6 is not a solution. All right, so that was important. That was important that you understand that when graphing a line, you're graphing the solutions. And this line right here has an infinite number of solutions. So that's going to be important when we talk about solving a system by graphing. Okay? All right, so first thing I need you to make sure you know how to do is to graph a line using slope-intercept form. Okay? All right, now let's look at this example. So let's solve. Now remember, we're solving a system by graphing. So let's solve this system. Solve the following systems. Okay, so number 1. So let's suppose we had this. Let's suppose we had y equals 4x plus 3 and y equals negative x minus 2. So we're going to solve the system. Now, sometimes the notation will look different depending on your textbook. So sometimes it'll look like this. Sometimes it may look like this, like a brace to indicate a system. All right. So you'll notice that in this lesson, I'll use both. Just to remind you, depending on the textbook you use, some will have a brace, some won't. Okay, but they will say solve the following system. Okay, so the first thing you're going to do is graph each equation. You're going to graph each equation, all right? So we're going to graph each equation. So graph each equation first. And so again, we're going to do this using slope-intercept form. Now notice that both of those equations is already in slope-intercept form. So let's look at the first equation. Y equals 4x plus 3. So the slope is 4, right? And the y-intercept is 3. All right, so on my graph, on my grid, I'm going to, remember to graph a line, you need 2 points. I already know 1. So my y-intercept is 3 right here, okay? And my slope is 4. Now remember the slope, remember rise over run? Okay, 4 means 4 over 1, right? Okay, so my rise is 4, my run is 1. So since my rise is positive, I'm going to go up 4. 1, 2, 3, 4. So you start from your y-intercept. Don't start from the origin. You start from the y-intercept. So 1, 2, 3, 4. My run was a positive 1, so I go to the right one, and there is my my other point. So then you use your straight edge, and I may need. No, I think I'm fine. So we're going to use our straight edge, and we're going to get this line right here. Okay. All right. So there's the line right here. That's the line. Y equals 4x plus 3. Okay. Now, how many solutions does this line have? does this equation have? So that equation that I just drew, I'm graphing the solution. So the solution to this equation are any point that lies on this line. Now let's look at the other equation. So my other equation, y equals negative x minus 2, the slope was a coefficient of x. So remember, the coefficient of x here is a negative 1. So the slope is negative 1. And my y-intercept is negative 2. Okay, not positive 2, negative 2. And it's a good idea to write your slope as a fraction, rise over run. So I'm going to write this as negative 1 over 1. Okay. All right, so to graph this line, my y-intercept, remember you need 2 points. I already know one of them. That's your y-intercept. So that's negative 2. So here's negative 2 right here. Okay. And my slope is rise over run, negative 1 over 1. So from this point right here, from the y-intercept, I'm going to go down 1 and to the right 1. Okay? So rise is negative, I go down. Run is positive, I go to the right. And then I'm going to connect, I'm going to graph that line through those 2 points. And I get something that looks like this. All right? So this right here, this line, I just graphed the solutions to this equation. Right here, solution to this equation. All right, now let's talk about the solution to the system. So if you notice, what do you notice about these 2 lines first of all? So the solutions to the first equation were all of these points. The solutions to the second equation were all of these points. What do you think is the solution to the system as a whole? What point satisfies both equations at the same time? This point of intersection right here. Right here. That point, the point where they intersect, is the solution to the system. So the solution to this system right here, the solution, and we're going to go ahead and write this as an ordered pair. So depending on what platform you use, sometimes they'll say write it as an ordered pair. So then remember your x coordinates negative 1, your y coordinates negative 1. So negative 1, negative 1. And then sometimes they'll say list them separately, so meaning x is negative 1, comma, y is negative 1. All right, so depending on the platform you're using. Many times, though, they'll just say write the solution as an ordered pair. So you would need to write as an ordered pair. Remember, x goes first, y goes second. So that's your solution. So let's check. Let's see if this actually works. All right, so let's check this. So remember, when solving a system by graphing, when solving a system period, you're finding the point that satisfies both equations at the same time. All right, so let's look at the first equation. Y equals 4x plus 3. So let's see if this point is a solution. So in place of x, I substitute negative 1. In place of y, I substitute negative 1. So negative 1 equals 4 times negative 1 plus 3. 4 times negative 1 is a negative 4. Is negative 4 plus 3 equal to negative 1? Yes. Now let's look at the other equation. So the other equation, y equals negative x minus 2. Now think of negative x as the opposite of x. That's the way I would think of this. So y is negative 1. And so is negative 1 equal to the opposite of x, which is negative 1, minus 2? Well, what's the opposite of a negative 1? Well, that's a positive 1. And is 1 subtract 2 equal to negative 1? Yes. So the solution to the system is this point right here. So the solution is negative 1, negative 1. That's your solution. Okay? So the point of intersection is a solution. No other point on this line, no other point on this line, no other point anywhere in this grid is a solution except this. Okay? All right, let's look at that example. All right, number 2. So number 2, let's suppose we had this. Let's suppose we had y equals negative 5/3 x plus 3. Negative 5/3 x plus 3. And let's say we had 3y minus x equals a negative 9. So 3y minus x equals a negative 9. All right, so we want to solve the system. Now again, remember that sometimes you won't have that brace, but it will say solve the system. So what you're trying to do, remember, is trying to find the point that satisfies both equations at the same time. So that point's going to be a solution to this one, and it's going to be a solution to this one. That's what you're trying to find. And so we're going to do this by graphing. Okay, well, first of all, notice that the first equation is already in slope-intercept form. All right, so let's look at the first equation. So y equals negative 5/3 x plus 3. So the slope is negative 5/3, and the y-intercept is a positive 3. All right, so I'm going to go ahead and graph that line. And so when I graph that line, I get this. So remember, the graph line needs 2 points. I already know one of them. That's the y-intercept. So that's where the graph's going to cross the y-axis, so right here at 3. And then I'm going to use rise over run to find the other point. So the rise is negative 5, and the run is 3. So from your y-intercept, you're going to go down 5. 1, 2, 3, 4, 5. And then remember, the run was a positive 3, so then you're going to go to the right 3. So let me do this again. 1, 2, 3, 4, 5. 1, 2, 3. All right, so remember, the slope is negative. Slope is negative, right? So your line's going to fall like this. So then we graph that line. We're going to graph that line, and I get something that looks like this. All right, now my point's thick on the pen, so it may not come out to be exactly where they're supposed to intersect. All right, now, so that's that first equation. Now my second equation is this. Okay, so I'm going to go ahead and write that second equation. All right, now remember, I want to graph this line, right? So I want to put this in slope-intercept form. So to get this in slope-intercept form, I got to solve for y. So I'm going to add x to both sides first, just like this. And so and then combining like terms, this is 0 right here. So I get 3y equal x minus 9. Y'all agree? And then to get y by itself, I'm going to go ahead and divide both sides by 3. So what I do to one side, I do to the other. And then 3 divided by 3 is 1. 1 times y is y. And what I'm going to do now is I'm going to write this as two separate fractions. So I get, remember this right here is 1, right? So I'm going to write this as 1/3 x minus, and then 9 divided by 3 is 3. So remember this right here is x over 3 minus 9 over 3, right? And then I just went ahead and I rewrote this to make it look like a number times x. All right, so x over 3 means 1/3 x. And then 9 over 3 is just 3. All right, so the slope is 1/3, and my y-intercept is negative 3. And so remember that since the slope is positive, the line better rise, right? It better rise. Okay. So to graph this line, I need to know 2 points. I already know one, the y-intercept, so that's negative 3 right here. And the slope is rise over run, 1/3, so I'm going to go up 1 to the right 3. So up 1 to the right 3. 1, 2, 3. And look, so I already know, without even graphing the other one, I already know where they intersect. They intersect right here. And so there is the other line. And remember the solutions, there are an infinite number of solutions to this equation, an infinite number of solutions to that equation. That's all these. Any point on that line is a solution to that equation. Any point on that line is a solution to the other equation. But you're solving the system. You are solving this system. So the solution to the system is the point that satisfies both equations at the same time, and that's the point of intersection. So this right here is your solution. And the solution as an ordered pair is 3, -2. 3, -2. That's your solution. So your solution, remember there are two ways to write it. You can say 3, negative 2 as an ordered pair. Remember, x goes first, y goes second. Or you can say x equal 3, comma, y equal negative 2. All right, and let's just check this. Let's check to make sure that this actually works. 3, negative 2. Let's see if 3, negative 2 is a solution. So you go back to your original, you go back to your system, the original equations, because you could have made, and the reason why you want to use the original is because you could have messed up somewhere around this process when you got y by itself. So always go back to the original. So that point right here better satisfy both equations. So let's check the first one. Y equals negative 5/3 x plus 3. So we're saying x is 3, y is negative 2. So let's see what we get. So I get negative 2 equals negative 5/3 times 3 plus 3. So in place of y, I substitute negative 2. In place of x, I substitute 3. So I get negative 2 over here. On this side, negative 5/3 times 3. Remember, the 3's divide out, right? Just like this. So I get negative 5 times 1 is negative 5. So is negative 5 plus 3 equal to negative 2? Yes, it is. Now let's check the other one. 3y minus x equal negative 9. So in place of x, I substitute 3. In place of y, I substitute negative 2. So let's see if that's a solution to this one. So 3 times y, which is negative 2, minus 3, and I want to see if that's going to equal negative 9, right? Well, 3 times negative 2 is a negative 6, and is a negative 6 subtract 3 equal to a negative 9? Yes, it is. So that's your solution. Okay? All right, so that was number 2. All right, so far we know this, that to solve a graph, to solve a system by graphing, you're looking for the point of intersection. All right, point of intersection. And notice that in these two problems that we just did, the solution, there was only one solution. There was only one point of intersection. All right, so each of those two systems, if you go back, there was only one solution. The solution was this ordered pair. Okay, so remember, no other point in this plane is a solution except this one. Okay, let's look at number 3. So number 3, let's suppose we had this. Number 3, let's suppose we had this system. Okay, suppose we had this system. I'll go ahead and use a brace this time. So let's suppose we had 2y equals negative 4x plus 6. And let's see, the other one is y plus 2x is equal to negative 1. All right? So I want to solve this system. All right, so let's look at what we have. So we're going to go ahead and do this by using slope-intercept form. And so the first equation, 2y equal negative 4x plus 6. To get y by itself, I'm going to divide both sides by 2, just like this. And so 2 divided by 2 is 1. 1 times y is y. And I'm going to go ahead and rewrite this as two separate fractions. So I get negative 4x divided by 2 plus 6 divided by 2, which becomes negative 2x plus 3. So make sure you simplify this. So now my slope is negative 2 and my y-intercept is 3, right? Okay, so let's graph this line. So my y-intercept is 3 and my slope is negative 2. So I'm going to write this as negative 2 over 1. So the rise is negative 2, the run is positive 1. And remember, since the slope is negative, your line better fall, right? Okay. So I go down 2 from this y-intercept. I go down 2, 1, 2, and into the right 1. So here is my line right here. All right. Then let's graph the other line. So the other line right here, y plus 2x equal negative 1. If I solve for y, subtract 2x from both sides, I get y equal, this is 0, so y equals, and then negative 2x minus 1. So the slope here is negative 2, and the y-intercept is negative 1. All right. Now I want you to notice something. You notice that the slopes are the same, right? So you may remember something from a previous course that you learned. So let's talk about this when we get to it. So let's first of all graph this. So my y-intercept's negative 1. So notice the y-intercept is negative 1, so that's right here. Okay. And my slope is negative 2. So same as this, I'm going to say negative 2 over 1. So from my y-intercept, I'm going to go down 2 and to the right 1. Okay. And so when I graph this, when I graph this, I get this line. So what do you notice about those two lines? First of all, remember, to solve a system by graphing, you're looking for the intersection. Do those two lines intersect? No, they don't intersect. They're in fact parallel, right? So those lines are parallel. And do you remember that if the two lines are parallel, the slopes are the same? Remember that? So two lines are parallel. So these lines are parallel. These lines are parallel. Okay, these lines are parallel since the slopes are the same. All right. And so since the lines are parallel, oh, and I better say this as well. So in this case though, what do you notice about the y-intercepts? The y-intercepts are different, right? So do those two lines intersect? No. Those two lines don't intersect. So there's no solution. So this, you would say, no solution, since the two lines don't intersect. All right, so no solution since the two lines don't intersect. All right, okay, now, but now these lines are parallel because the slopes are the same, so just keep that in mind. They are parallel, the slopes are the same, but they have no solution because the lines don't intersect, okay? The lines don't intersect. All right, now let's look at this example, number 4. Oh, by the way, so in the blank, you would just say no solution. That's what you would say, no solution. So in the blank for solution, you say no solution. All right. Okay, let's look at number 4. Number 4. Let's suppose in number 4 we had this. All right, let's suppose we had these two equations. Y equals 2/3 x minus 2, and then the other one is 3y minus 2x equals a negative 2. All right? Okay, so we want to solve this by graphing. So let's look at the first equation and let's graph it, see what happens. So y equals 2/3 x minus 2. All right, so 2/3 x minus 2. So the slope is 2/3. The slope is a coefficient of x. And the y-intercept is negative 2. All right, and so I'm going to go ahead and plot those 2 points. And so when I do that, remember you graph the y-intercept first. So the y-intercept's negative 2, so right here. And remember the slope is positive, right? So the line better rise. It better rise. And so my rise is 2, my run is 3. So I'm going to go up 2, 1, 2, and then to the right 3. 1, 2, 3. So there's my other point. So then I'm going to graph this. Okay, right here. All right, and then let's look at the other line. So the other line, we have 3y minus 2x equal negative 2. And so to get y by itself, I'm going to add 2x to both sides, just like this. And so I get 3y equal 2x minus 2. And then I'm going to divide both sides by 3, just like this. Remember, what you do one side, you do the other. And so 3 divided by 3 is 1. 1 times y is y. And then remember, we're going to go ahead and write this as 2 fractions. So I get, now let me go, I forgot to change this. I'm so sorry. Let me change this to 6 right here, negative 6. Put this negative 6 right here. And the reason is because I wanted those two lines to look a certain way. So I'm going to have to fix this to negative 6 right here. Negative 6. Negative 6. Okay? All right. And the reason I'm doing that is because I want these to be a certain type of lines. You can see what I mean in a little while. All right, so let's go ahead and write this as two separate fractions. I get 2/3 x minus, and then 6 divided by 3, right? Which is 2/3 x minus 2. All right. Now I want you to notice something. What do you notice about those two equations? They have the same equation in it. Isn't this equation right here and this equation here, which in this equation I can write it like this, isn't the graph the same? So when I graph this equation, it's the same graph, right? So I'm graphing those two lines. I'm graphing those two lines now. What do you notice about the intersection of those two lines? They intersect at an infinite number of points, correct? They intersect at an infinite number of points. And so this system right here, this system has an infinite number of solutions. An infinite number of solutions. So how many solutions does that system have? It has an infinite number of solutions. So again, we're solving this system, right? So these two lines, when I graph those two lines, they turn out to be the same line. So they overlap. Those two lines overlap, right? So notice the slopes are the same and the y-intercept is the same. Slope is the same, so the slope is 2/3, and the y-intercept's -2 for both of those. So those two lines overlap. And so since those two lines overlap, how many solutions does this system have? An infinite number. They intersect in an infinite number of points. Okay, so any point on this line is a solution to that system. So this system has an infinite number of solutions. Okay, now remember that this system has solutions, right? How many does it have? An infinite number. Okay, now in another lesson, you're going to learn how to write that solution, those solutions. But for right now, I just want you to know that this system has an infinite number of solutions. So I want you to notice something in number 3 and number 4. In number 3, the slopes are the same, correct? In number 4, the slopes were also the same. But why is it that in number 3, we had no solution, and in number 4, we had an infinite? That has to do with your y-intercept. What did you notice about the y-intercepts here? The y-intercepts were different. What did you notice about the y-intercepts here? The y-intercepts were the same. Okay, so if your lines are parallel, and they don't overlap, meaning that the y-intercepts are different, then you have no solution. If the lines are parallel and they overlap, meaning they have the same y-intercept, then there's an infinite number of solutions. Okay? All right, so that's going to take care of this lesson. Let me say this one more time. So one of the things I need for you to remember is this: when solving a system by graphing, one of three things will occur. Your lines will intersect at one point, so you get one solution. Or your lines could, if this is the x-axis and this is the y-axis, your lines could be parallel, right? Your lines could be parallel. So they have the same slope, different y-intercepts. In this case, you have no solution. Then the other thing we saw is that your lines could overlap. So they have the same slope, but and the same y-intercept. They have the same slope and same y-intercept. So if they overlap, you have an infinite number of solutions. So as you go through these lessons dealing with solving systems, you're also going to learn how to solve systems by substitution. You're going to learn how to solve systems by elimination. As you go through this, so notice that in some cases you'll have one solution, in some cases you'll have no solution, and in some cases you'll have an infinite number of solutions. Okay, so that's going to take care of our lesson on solving a system by graphing.